Michael went to the driving range with his rangefinder and hit 75 golf balls with his pitching wedge and measured the distance of each ball traveled in yards. And we have a table here for those 75. Now what we can do is open this up in Stack Crunch. And it's been a little while since I tried to get it to do a histogram, but let's see. Graph and histogram, our distances are in variable 2, named distance. So we don't care which time it was that he hit. We care what the distances were. Should be enough. Guess we want relative frequencies. No. Yes or no? We do. See what we come up with by just going to compute, I guess. Now, first off, if I close that, choices A and B cannot be possible. Those are frequencies. We want relative frequency, which is essentially the same as empirical probability. So it could only be choice C or D. And as we take a look here, this is starting at 96. That's looking most like choice D as opposed to choice C. The direction of the skew appears to be different. Now, it's definitely not uniform because it doesn't look nearly flat. It doesn't look nearly horizontal. It doesn't say anything about skew. Although it's not perfectly symmetric, my guess is, thinking about the law of large numbers, that probably if he were to do this several times, do the 75, then do another set of 75, and then another set of 75, etc. Or just increase the 75 up to 100, 200, 1,000, then eventually we'd start to see something looking more and more normal. So let's see if that's what they want. It is. So we're saying this choice, and they want us to draw a normal density function. I draw the normal curve over that. It's going to look most like D again. Could possibly be D, but My guess is they're looking for this. The heights are of the rectangles are getting close to the heights of the curve. Okay, again, think about the law of large numbers. What would happen if you increased his number of trials or did several sets of 75 and took averages?